All right. Hello and welcome back, everyone. This is Nick Does Algos, and in this lesson, we'll be covering the Hackerrank easy rated algorithm fair rations. In this question, you are a ruler in the feudal period of Hackerrank Castle, and you've got a bunch of subjects, and you are handing out some breads. But you are only handing out to breads. You are only handing out breads to individuals who come to you who currently have an odd number of breads. And not only that, but when you give them a bread, you are giving a subject directly next to them a bread as well. You can hand it to the left or to the right, but at the end of the day, what you're trying to do is have all of your subjects have an even number of breads. So let's quickly walk through this example here that Hackerrank provides. You've got four subjects. First subject has 4 breads, second has 5, third has 6, and fourth has 7. You would walk through this array of subjects. Your first subject has an even number, so you can ignore them. And then notice that your second subject has an odd number of breads, so you'd give them one, and you might as well give the subject to their right another bread as well. So this subject would then have 6, this subject would then have 7, and these last two subjects would both have 7 at that point, so you'd give each of them a bread, and you would wind up with this scenario where all of your subjects have even numbers of bread, 4, 6, 8, and 8. But of course, that's not the only scenario you could run into. You could run into a scenario where it is impossible to have all of your subjects have an even number of bread. And we see that exemplified here, where your first subject has 1 bread and your second subject has 2. If you make one even, well, you've got to increase the other, and that forces the other to be odd. So let's head over to Replit and run through some more examples and find a pattern that shows when you would run into impossible scenarios where you cannot have all of your subjects have even numbers of bread. So we know the one that won't work is when your first subject has 2 breads, your second subject has 1. Let's go ahead and add another hypothetical subject who has an odd number of breads. And you could use 3, you could use 4, or sorry, you could use 3, you could use 5, you could use 1, any odd number. Let's just go ahead and use 3. You'll quickly tell that you could increase that, or keep that guy the same, increase them and increase them, and now you've got a solved array. Okay, so here you'll notice that you have an even number of odds, and that's really what we're looking for. Let's go the other way and do, let's increase the length, and you've got 4 subjects, and 1 subject has an odd number. Let's increase that number. Let's go 2, 2, 2, and 3. You've handed breads to these last 2 subjects. Okay, now you would have to hand out more breads because you've got some odds, and you would do this, and you've still got an odd, so you'd go like maybe this. And you'll notice that you can't solve it. You just keep running into a scenario where somebody has an odd number of loaves. And so what's the quick pattern that you're noticing? It's that anytime you have an odd number of individuals with odd loaves, you can't solve it. So here you have 2 individuals with odd. That means you can solve it. Here you have 1 individual with odd. That means you can't solve it. Let's say we added 2 more. Now you've got 3 individuals with odds. You wouldn't be able to solve that. Anytime you have an odd number of individuals with odd loaves of bread, you cannot solve this problem. So let's first get that out of the way. Let's create a counter. Let's initiate a variable odds that will keep track of our odd values in our array of B. And then we'll loop through B, and we'll do for num in B if num modulo 2 bang equals 0, odds will go up by 1, plus equals 1. And what did we just do here? We looped through our B array. We evaluated whether the number that we're at, our instance of our number loop, if it is odd or even. That's what you write here. This is saying if the number is odd, we will increase our odd counter by 1. So if this is working, we would go ahead and print the odds and see that we would get 2 because we have 2 odds in this array, right? 3 and 5 are our 2 odd numbers. So let's go ahead and print. And there you go. We have found the odd numbers. So that means that this scenario is solvable. But let's first take care of scenarios where it's not solvable, right? So let's not do the work to find the answer of the number of breads that we're going to hand out. Let's make the conditional statement that says, if it's not solvable, don't solve it. And then we'll take care of the else that is the solvable version. So what's our unsolvable, sorry, my cat is going crazy. What's our unsolvable condition? If odds is odd, if odds modulo 2 bang equals 0, we would just simply return no. And that's given by Hackerrank. Hackerrank says in the scenario where you do hand out loaves, you will return the minimum number of loaves as a string. If it's not possible, you return the string of no. And that's what we do there. And then, of course, we go to our else condition where we will actually solve this problem. We'll actually find out how many loaves of bread we have to hand out. So let's first initiate a breads variable that will increase as we hand out our breads. And we'll want to loop through our B array and evaluate each position and see if the position we're at is odd or even. If it's odd, we'll give them a bread, and we'll also give a bread to the person to the right of them. And then we'll jump to this next position, evaluate that position. Is it even or is it odd? If it's odd, we'll give them a bread and give the person to the right of them a bread. And then again, jump to the next position and do the same thing. So the best way to do that is to do an I loop, or a range loop. And the reason being, if we are doing something to the position we're at, we need to do something to the position next, so we can write that out as I and I plus 1. So we're going to go ahead and write an I in range loop. So for I in range length of B, and we'll do length of B minus 1, because length of B minus 1, you would do that because you don't really care about this last position. This last position will be taken care of when this position is evaluated. The second to last position is evaluated. And you can do that because say you run into a situation where the last variable, the last subject is odd. Let's do evens 4, 4, 4, and odd. Well, in this scenario, it's not possible because you have an odd number of odds. So you don't need to worry about this last position. In all other scenarios, by the time you get here, this number has at least become even if it didn't start even, meaning it would be like this. Or you would do 3 and 3, and then these two are taken care of as you loop through and edit, and you would wind up with an array like that. So that is why you would not care about the last position. And you also, that's it really. I'm going to add a tidbit that I didn't need to. Okay, so we are looping through our i's, our instances of I, from 0 to the length of our array minus 1. And what would we be evaluating? Well, we're evaluating if the number we're at is odd or even. So if B of I is odd, if it is odd, we're going to do something, right? So if B of I modulo 2 is odd, is not equal to 0, we're going to do something. We're going to increase B of I. We're going to give them a bread. B of I becomes B of I plus 1. And not only that, but we'll evaluate the individual to the right of them, who is B of I plus 1, and we will B of I plus 1 increase that as well. So we've increased the values, but what did we not do? We didn't keep track of handing out our breads. So we gave out 2 breads, and in a scenario where we're handing out 1 bread, we're always going to hand out another, so you can increase your breads by 2. So there you go. Now we should have an updated B. So let's print B to check out what it is, make sure all of our numbers are even. There you go. We ignored the first guy. He had an even number. He was fine. We increased the second. So they now have 4. This one became 5. And then you evaluate that one. You say, oh, that's odd. We need to increase it. So 5 becomes 6, which causes this, which was a 5, to become a 6. And then your last one is already a 6. So you don't need to do anything to them. And of course, we can go ahead and print our breads to make sure that we are keeping track of our breads. And there you go. And there is one last tidbit just to make Hackerrank happy. You would have to return the string of breads, just because that's the format that they're asking for in this question. So let's go ahead and copy and paste this over to Hackerrank. Let's copy and paste it. As I mentioned, I used the lowercase b. The old version has a capital B. So just make sure you're consistent with that. I'm sure you would probably bang your head against the wall for a little while, but eventually realize what the issue is. Don't need that. Let's get this all formatted. You would go up. Oh, I see what's happening here. I was like, what just happened? Okay, there we go. Increase you, and I think that should be our format. And there you go. We passed both of our sample test cases. Let's run this against all of our test cases. And there you go. Nice and easy. Not too complicated. Just a couple conditions that are impossible that you've got to be aware of. This question has a pretty small big O time. So it solved all of these questions pretty quickly and got through all of them, even though I'm pretty sure they get quite big at the end. So I hope that helped you guys out. If you have any questions at all, please feel free to drop them in the comments below. If you did enjoy this video, if it did help you out, please go ahead and hit the like button. And we're covering these problems just about any given day. So if you're at the point in your career where you're covering algorithms, you're going to want to go ahead and hit the subscribe button. I'm sure we'll be able to help you out again at some point. But thank you so much for watching, and hope to see you in the next one.